Welcome to Think Global Education Services. Today's topic is kinematics, rest and motion. Now let us take an object which is traveling in a straight line. Now, this is the distance traveled by the object. If the object traveled this distance in time t, then speed equal to distance divided by time. Now, there is a difference between distance and displacement. For example, let us take a reference frame. Reference frame is nothing but a frame of reference, that is a particular coordinate system which you can take, and within which the coordinate system the object is traveling. This is an x, y, z plane, and here the object is traveling from this point A to B, and it travels like this. And here is B, and it goes to C, and then it travels to B. Now here, if we calculate the length of A to C, C to B, then it becomes distance. If we calculate the length from the starting point A to the ending point B, then it is called as displacement. So displacement is the distance between 2 points in a plane A to B. It does not matter the path, the displacement does not take the path into account. That is, it takes the shortest distance between the 2 points, that is the displacement. And velocity of any object which travels in this plane is defined as displacement over time. And here we can represent displacement by the letter S, and time, the time at which it starts is, let's just say, t1 is the time at which it starts and t2 is the ending time. So displacement over the change in time is represented by velocity. And here it has the units meter per second. So now what we can do is that we can take this and we can write it in a different way. That is, we can calculate what is the average velocity of an object which travels in this plane, which is nothing but which is equal to displacement over change in time, and we can write that as delta s by delta t, and which is, now if we take a limit to this, so limit delta t goes to 0, delta s by delta t, then we will get ds by dt in this graph. And this is called as the average velocity. Average velocity is nothing but ds by dt, and here, as we can see, ds by dt is nothing but the gradient of the slope of this curve. So gradient of the slope of the curve gives us the average velocity of an object. Now we can discuss about instantaneous velocity. Instantaneous velocity is nothing but, let's just say the object is at this position. At this position, what is the velocity of the object? So that is the instantaneous velocity. Velocity at a particular position and a particular time. We can mark the particular position, the particular time gives us the instantaneous velocity. So now we can draw a graph for s versus t and then see how we can find it out. Let us say this to be the two lines here, two axes. There is s and here is t. S is displacement and this is time. Let us say the object starts from position z, position 0, and then it goes like this. So here, as we know, if we measure the slope, this becomes ds, this becomes dt. Now we can take it as del s and del t, and you can divide it, and then we can get the average velocity. Now at this position, what is the velocity? That becomes the instantaneous velocity at a particular position, in a particular time. So if we calculate the slope of this curve, we get the average velocity. Now if we draw another graph for velocity versus time, Now we'll just take this is time t1, this is time t2, and the velocity at time t1 to t2, it changes like this. Now here, if we calculate the area underneath this curve, to calculate the area underneath the curve, we need to take the integral of the curve. So what we can do is that we can take the integral of the curve. Let's just, the curve can be velocity as a function of time. That is the curve. So if we take the integral of this curve, we take integral, we can represent as I, which is equal to integral from t1 to t2 of v dt. Since v is a function of time, we have to differentiate it with respect to time. And when we take that, what we will get is yes. Yes is nothing but the displacement. So if we take the integral of the curve, we get the displacement. We can see that here, since v is nothing but ds by dt, and here is another dt, so it gets cancelled. So what we will get is t1 to t2 ds. So where the object is at time t1 minus where the object is at time t2 minus where the object is at time t1. So we get the distance traveled by the object in the given period of time. So that is what is the integral underneath the graph of velocity versus time. So this is for objects which has constant velocity. That's what we are discussing. Maybe constant or increasing velocity, like that. So now let us discuss about objects which has a constant acceleration. Now when an object travels with a constant acceleration, we can write the equations of motion for an object and find out what is the velocity or position or the or the instantaneous velocity of the object at any given time. So first we can describe that the object is traveling with a constant velocity. So it has a constant acceleration. Yes, there's a constant acceleration. So now if it has a constant acceleration, then we can represent the acceleration as the change in velocity. Or if we calculate the slope of a velocity versus time graph, if you take a velocity versus time graph, this is time, this is velocity, and let's just say it's like this. So this here is dv by dt. This represents the constant acceleration. Now we have dv by dt. Now what we can do is that we can rewrite these equations as dv equal to a into dt. So I'm multiplying by dt on both sides. Now I can integrate this equations of v2 u1 to v2 dv equal to a is a constant one, so we can take the a out, t1 to t2 dt. So what we will get is here v2 minus v1 equal to a into t2 minus t1. So here we can represent the v1 as the letter u and v2 as the letter v, which is equal to a into, and t2 minus t1 we can represent just as time t. So what we will get here is that v equal to u, so I'm adding u on both sides, plus a into t. This is the first equation of motion. Now what we can do is that we can take this equation of motion, v equal to u plus at, and square it on both sides. So e squared equal to u plus at squared. So if we do that, we get v squared equal to u squared plus a squared t squared plus 2 u a t. Now we can keep the u squared as it is. Now from these two quantities, we can take 2a as a factor. So what we will get? We get ut plus half. Since there is no 2 here, we have to multiply by half. We have taken 1a out, so we'll get just 1a, and here 2t squared. Now from this, what we can get is that Here, as you can see, ut plus of at squared is there. Now we can leave it as it is here. Now we can go to other part, which is dx by dt or ds by dt. In this case here, ds by dt is nothing but change in displacement over time, which is equal to u plus at, because as we can see here, this is velocity, which is ds by dt. So here what we can do is that we can keep the ds here and we can multiply dt on both sides, so we'll get plus at to dt. Now we can integrate it from 0 to s ds equal to 0 to t 0 to t, we can take it as 0 to t u plus at dt. And when we integrate it, what we will get is that s equal to ut plus of at squared. Now I can integrate it here. It will integrate as 0 to t u dt plus 0 to t. We can separate the integrals to make it easier. At into dt. Now, since there is no t here, u is a constant value. So when we integrate dt, you will just get t from 0 to t plus a is again a constant, and t, when we integrate t, we'll get t squared by 2 0 to t. So now we get the value s equal to ut plus of at squared. Now as you can see, s equal to ut plus of at squared. So now you can substitute that value here. So what you'll get is u squared plus 2a yes v squared equal to, this is v squared here. So this is the second equation of motion and this is the third equation of motion. So these are the three equations of motion that we need to calculate or to figure out any other values. So here v represents the instantaneous velocity, s represents the displacement, and a represents the acceleration. Now in case if you have a freely falling object, an object which falls freely, then the equation of motion of that object is different. You can easily write that v equal to u minus gt, since as you can see here, this a is replaced as minus g. Since the object is freely falling, it is acting only, the force that is acting is the gravitational force, so it is falling under the influence of gravity. So it is falling. To indicate that it is falling, we are just representing it with a minus here, and it is falling with acceleration due to gravity value g. G is the acceleration due to gravity, so minus gt. Now if we do that here, s equal to ut minus of at squared will become gt squared. It is minus g since it is a freely falling object. Now v squared equal to u squared minus 2, and it is as will become g. Yes, so this is the equation of motion for a freely falling object. You can use the three equations of motion along with the freely falling objects equation of motion to calculate the position, velocity, and the time or even the acceleration of an object which is moving. Thank you for watching.